A very good day to my students. In this particular video, we will be discussing industrial engineering techniques in Unit 4. Basically, after plant layout, we will be discussing industrial engineering techniques. So, this is what we are discussing. Now, industrial engineering testing is four types: capacity study 1, work in progress 2, operation bulletin 3, and performance standardization. So in capacity study, what are the things we have to do? That is the capacity of the production plant per day, per hour, per month. So get the necessary details of operation like job and machine. We have to get the details. Once the method is implemented, take 10 single cycle of observation with the help of a stopwatch. So reading of a particular operation has to be taken 10 times and the average worked out. One operation we call, the terminology used is cycle, one cycle, that we call single cycle operation. So single cycle operation, same operation at different times of the day, time study is taken. And the average is called single cycle observation. Once the readings are noted, calculate the average observation, arrive at the capacity of the operator. So that is what it is. Different times of the day, you take 50 readings, take an average, and that becomes the capacity of that particular operator on a particular machine and doing a particular work, type of work. The cycle consisting of breakdown times such as machine delay, handling bundles, etc., should not be considered for calculating average SE time during capacity study. Yeah, we were discussed very clearly in time study. That is, we have got a rating factor, the speed of working of an operator, and then allowances. So these things should not be taken into account. Then another thing, the reason behind the above delays will occur irrespective of operator's capability or capacity. So these delays cannot be considered as a measure of operator's capacity. So machine breakdown, the operator purposely doesn't may repair the machine. It accidentally happens. Only by preventive maintenance and regular maintenance by the maintenance team they can do it. So that will not come under operator. However, these delays will definitely reduce operators' actual performance. Handling bundles, see the left hand side, machine delays, that is thread breakage may be there, bobbin change may take place, changing thread because 200 meters is consumed, etc., comes under delays. Then breaks and personal time. Okay, that is not thing. That is personal time is what I would like to tell you is earlier, whichever industry our laborer was, he used to go for a smoke and he used to go to the restroom and then he used to smoke there. So that is now avoided in modern era, but he is allowed to go to the restroom several times. And sometimes because he's tired, he takes a break. Even for drinking water, there's a drinking water area you can go. Those things uh, happens regularly. But all this makes the reduction of operators' performance. So when you are checking the individual performance, his performance reduces. That is, more time it takes for him to produce. So the IE techniques finally come down to calculation. So operator where Sam, assuming standard allowed minutes is 0.5, 0.45 minutes. That is nearly a half a the figure for 5 minutes works out to 28 seconds. If that is a particular operation, single cycle at 100% is 41 minutes, 0.41 minutes. Type of machine is single needle lock stitch and average observed time is 0.65 minutes. Then the quota, target at 100%. Working time in minutes by SAM shift duration. That is, working time is 8 hours, into 60 is 48 minutes, into 60 is 480 minutes, divided by the SAM, that is standard allowance, 0.45. So the capacity is 1066 pieces. Okay, that is what the capacity for 8 hours. Single cycle efficiency is equal to single cycle at 100% divided by average observed AC time. That is, single cycle efficiency is 0.41, average time is 0.65. So efficiency is only 63%. Now the capacity is your quota is 1066 shirts into efficiency 63%. That is 63 by 100 or 0.63, 671 pieces. So the capacity per hour per day is 671 and for per hour divided by 8 is 83 pieces. So this is how calculation is done. We immediately think after taking some readings that 1066 pieces can be made. No, it is they can only make up to 6,671 pieces because efficiency comes down. Now, what are the benefits of this capacity study? You can check the targets regularly. Okay, motivate the operators if they give a slightly lesser, because every hour you are checking at regular intervals, you can motivate them to attain the capacity. Then measure section production capability. If you say section, assuming there is a sewing section, it is producing three different products at the same time. So each product section capacity can be checked, measured. Then check targets. That is the first one. When the operation bulletin is prepared, the targets are set based on balance efficiency. Planned efficiency is 60%. But it would be impossible to expect all operators in a line to work with same efficiency. Exactly. This is the same for any sector. You are working as a group, everyone will not work equally, and you cannot expect. Okay. So then you have to take an average and work out. Once capacity study is done, the targets for every operator on an operation can be checked with the capacity study and balancing can be made. This is where industrial engineering work comes. So proper balancing can be made in that. So this is what to attain different targets. Then another IE technique is operator an exercise. This is basically an exercise what we discussed in the earlier slide. That is, I've given you some a sum. How to get the answer? That is the quota or target per 8 hours. How to get the efficiency and capacity? Apply the formula and you can get it. Then the second one in industrial engineering techniques is the work in progress. The semi-finished or finished goods which transported from one station to other is called work in progress. Simple. Raw material is fed into a spreading table and then it is given and it is cut. It comes as a final garment outside. Say like 1,400 shirts, each shirt contain 2 meters, 2,800 meters are produced per day. At any point of time, 2,800 meters of fabric is the work being done or work being processed to convert it into a final product. So that is what is work in progress. It is made up of all garments and their parts which are not completely finished, but it can be measured in pieces or in minutes. That's what they say. Example, if an operator takes 0.8 minutes per piece to stitch, and if she has three bundles of 10 pieces each to be processed, then the work in progress in that station is one bundle is 10 pieces, three is 30 pieces, and she has around 24 minutes into 30, 24 minutes to complete that. So this is what it is. Then why we need work in progress? What? So now how we have to control this? Inventory is money invested in raw material. See, find out whatever product you are having. You have to keep some stock. Stock is money blocked. Please understand an unofficial definition I'm giving based on experience. What is stock? Stock is inventory. That is a modern name. But what is invested? That is your money is invested. So stock is money blocked. Straight away you can take it from me. But we need a certain percentage of stock for every operation, for every product in the world. Then what to do? How much stock to maintain? So inventory is moved through the plant quietly, then it affects cash flow directly. So that's the problem. If that stock is moved, not moved properly, your cash flow, that is your money gets blocked. Ability to reduce production cycle. By having low inventory between operations, governments usually have less waiting time and go through the production cycle at a less time. So what happened is, so waiting time is less, so total production time, you can get more number of garments. Large inventory levels between operators keep the goods waiting longer. More money is blocked in work in progress. This increases the overall time and also the cost of the product. Low throughput time is time needed to make one garment. Permits better coordination between sales and production. Low cycle times give manufacturers to handle multiple styles, and clients or buyers are looking for factories that can meet production schedules, that can handle multiple styles, and that can handle low inventories, which reduce the investment. Factories that work with low work in process will only be able to survive in today's present market. Okay, if that is the case, how do you we'll look at this at the next thing. How to manage work in progress. One is by production planning, proper production planning. And the second one is trims control. What is production planning? Trims is all accessories that go to make a garment. Examples is given here: zippers, labels, threads, elastic. And then the production build up. This is based on what is the capacity you can do with the present labor. This can be done. And finally, line balancing. So this is where uh, it all depends on what is the absenteeism of the labor, what is the turnover, absenteeism turnover, and how many times you change your style. And one is the operation which is done first is the cutting operation. If bad cutting is there, then again it affects your balancing of operations. So this is what it is. Then cut flow control, cycle times, how much one particular process, how long does it take? Can it be reduced? So that is what Aikitai is about. So thank you very much.